So today I'm covering writing algebraic models. So this is something that's really important when we're dealing with applications of algebra. We're going to be doing a lot of word problems throughout the term. And so this is like starting with the basics of how you start taking the words and translating them into mathematics and understanding what the words mean. So it's really just the beginning of a lot of what you will be doing when you're encountering word problems. So first, what is mathematical modeling? What does that mean when you hear that? So mathematical modeling is the process of taking real life situations, so things that you encounter in the real world where you may need to use math, and then you are taking those situations and you're translating what's happening into expressions or equations that then you can go on and solve. So the process of mathematical modeling is really important. This is really a good way to learn critical thinking skills. So even if you are not going on to a degree or a program where you have to use a lot of math, you're still learning some valuable skills by going through mathematical modeling because it helps you kind of get logical thinking. So you have to do a lot of critical thinking to kind of understand how things are put together. There's problem solving. You are directly translating words and phrases into what they mean mathematically. And you need to have some understanding of mathematical concepts in order to really put these things together. So I do have a link here that has examples of mathematical modeling that when I email out the PowerPoint, you can then review later on your own time. So when we talk about algebraic models specifically, this is something that uses algebra. So you're going to be using variables in your equation or your expression when you're representing a real world situation. So most mathematical models are algebraic models because we generally have variables that we are looking to solve. So there are lots of categories that these fall into, and you'll see these kind of types of problems over and over again. And so the more you see these types of problems, the more you understand this is how I set it up, and you start finding the connection and seeing that every problem that looks like this gets set up this way, and so on. So we've got direct translation problems where you are taking whatever you've got written in English and you're translating it directly to mathematics, and that relies on understanding what the words mean and what symbols they're referring to. We've got consecutive integer problems where you are basically taking integers or numbers that are one after another, like when you count. There's problems that involve finding totals. We've got geometry problems, and there's different types of those. You can have problems involving area, perimeter, different angles. There's distance, rate, and time problems. So those are very, very common. There are a lot of different problems involving percentages. So there's a lot of things you can do. You can do tax calculations, interest calculations, tip calculations, markup if you're running a business, discounts, commission. There's lots of different problems that fall into that category. And then there are mixture problems where you are mixing things together, and those tend to pop up in chemistry. So these are the most basic, these are the most frequent type of models that you see throughout our class. As you're going to see these types, and they're going to come up over and over again, and you're going to learn different techniques for solving them. What I'm focusing on today is the direct translation ones, because that's the most basic, where you really have to understand what the words mean and then how that turns into the correct symbol or the correct operation, whether it means you're multiplying or adding and that sort of thing. So direct translation is like the basis of every problem that goes on from there, because if you don't understand the basic vocabulary, you will struggle trying to set up the problems after that. So that's what I'm going to be focusing on today. So this PowerPoint will get shared out, so you'll have a copy of it. So if you're wondering, like taking notes and stuff, I would write down the problems, and you don't have to write down like every little word, because you can fill that in with the PowerPoint, or if you prefer, you could just watch and just kind of listen, and then you can always look at the PowerPoint later, or rewatch the recording on your own, however you need to, whatever you think is going to be best while you're learning here. But I encourage you to stop me and ask questions. So we're focusing on direct translations, and these rely a lot on vocabulary. So generally what you're doing is you'll have a word problem, and you need to translate those words into math. And so you're looking for specific words that tell you what operation you're doing. And so this is a list of words that, there are words that mean addition, such as added or adding. You've got more than, which refers to addition. The sum, so sum means addition. Increasing means you're adding on. The total, whenever you see a total problem, you're adding things together. Words that mean subtraction. You've got minus, less than, decreased, difference, literally the word subtract. Words that indicate multiplication. Times, twice, that means specifically multiplication of 2. The word of means multiplication. Product is multiplication. Of course, the word multiplied. Words that mean division, you've got divided. Quotient is a word that means division. Ratio is another word that means division. And then things that represent exponents or like roots. So the square of means that you're taking an exponent of 2. The cube of is an exponent of 3. And if you see square root, so it has to have the word root, then that is the square root symbol. So you have to be careful that you're reading the whole thing, because you don't want to get the square and the square root confused, because those are two different things. So you really have to pay attention to all of the words. So math that is very detail oriented. You have to pay attention to every word and understand what each of the words mean. And then you have to be able to correctly translate that into the math. So with the addition words, the order that you write your things that are adding doesn't matter. But for your subtraction, the order that you write them does matter. So some of the words you can translate directly left to right as in the order that it's said, but some of them, I have them highlighted, less than and subtract from, get translated backwards. They're in the opposite order. So you have to know which words get translated directly as you go left to right, which ones are backwards. The order doesn't matter for the multiplication problems, but for division, it does matter. You always have to do the first one and then the second one in that order. You can't just kind of flip them around. So you have to pay attention to the word, because that helps you understand how to translate it. So when you get the PowerPoint, you might want to print this slide out just so you have something to reference. And then you have examples so you know how to translate those. So there are some general rules when you're translating that can help you out. So if you have a phrase, so if I know people usually say they're English people or math people, they're one or the other. So a phrase is, in English, is an incomplete sentence or incomplete thought. That is equivalent to an expression in math, which means that there's no equal sign. And if you have an expression, then you see the words less than and more than, that generally translates as subtraction or addition. Now, if you're given a sentence, then that's equivalent to an equation. It has a complete thought. And so those will always be translated with an equal sign. And you look for the verb in your sentence, the action, that's where your equal sign goes. And usually the word is where you put the equal sign. And then you see words like than or and, those usually get translated as plus signs. And then if you see something that says X in terms of Y or other variables, that is telling you that if it's X in terms of Y, you have X equals, and then whatever follows is going to have a Y in there somewhere. So it's telling you what you're setting, which variable is on the left of the equal, and then where all your other stuff is. So you really have to pay attention to these words because they are clues telling you what to do. So we're going to just start with examples of expressions. So these are incomplete thoughts. So the first one is 8 subtracted from X. So when you're translating this, this is not a complete sentence. It's not meaning anything. Like it's not a complete thought. We just have 8 subtracted from X. So there's no equal sign. There's no verb here really other than subtracted, but that gets translated as a minus sign. So the word subtracted that is a minus. And when you see the word from, subtracted from, that is telling you that whatever you're subtracting is after what follows. So this is indicating that we're translating this in reverse order from what we see. So when you're reading this, you've got 8 and then X, but that word from is telling us we're going in the opposite direction. That it's whatever we're going to do is going to be after the X. So that's telling us that our X is going to be first. So we've got X, we have the word subtracted. So that subtracted from tells us our subtraction is after the X. And then the only thing we have left is 8 because we have not translated 8 yet, other than we haven't done anything with it. That's the last word that we have to deal with. So this gets translated as X minus 8. So when you read this, 8 subtracted from X, the 8 is being taken away from X. That's why it has to follow the X, because it's being removed from X, so it has to come after X. The next one we have here is X decreased by twice T. So this is another phrase, so there's no equal sign here. And decreased is another word that means subtraction. And decreased by, so that's just going to be in the same order, so you don't have to reverse it. So we just translate it left to right. So we have X, we have the word decreased, and then we have to translate this twice T. So twice means 2. That means that's a word that means we're multiplying by 2. So it's going to be 2. And then when we do multiplication, we might use use a dot to indicate multiplication, or parentheses. We never use the X because X is a variable. So we're going to do a dot, and then it says twice T. So that means 2 times T. So when you put this together, this translates to X minus 2T. There's nothing we can do. We can't solve. We can't figure out what X is. We can't add these together because these are expressions. There's nothing to do. You're just taking these words and then translating them into what they mean mathematically. Are there any questions so far? Okay.
Can you hear me?
Yes, I can hear you.
Okay, this is what I was telling you about this morning. What I was trying to do, the dot was that the 2.t, the shortcut to the multiplication.
Yeah, you wouldn't write it in Alex. You would just put 2t.
Okay.
So when we write our final answers, we don't normally keep the dot there. We will put them together. So it's just written as 2t.
Okay.
There are other questions. Okay. So here's two more examples. We're doing the same thing. So we'll start with the top. We have twice the sum of m and n. And my pen seems to be dying. There we go. Okay. So I work my way left to right. So twice means you're doing 2 times something. So I'm just going to write 2 and then my multiplication symbol just to indicate that I'm multiplying by something. And what I'm multiplying by is everything that follows the word twice. So I am multiplying that 2 by the sum of m and n. So since I'm multiplying by lots of things, lots of words here, I need to group those together with parentheses. So if you are doing multiplication and you have lots of things after it, those get put in parentheses to kind of group that together. So now I need to translate the sum of m and n. So we've got the word sum, and that means addition, and that always gets placed where the and is. So if it was said the difference of, then the symbol for difference would go where the and is. So you put it where the and goes. So that's sum means addition. So we're going to have a plus sign there. And then we have m and n. So I can just put in those variables in the order that I see them. So I've translated twice. I translated the sum of, I translated the m, I have the and the n. I basically have looked at every word here and translated. So now when we kind of put this together and write this, we would have a 2, and then we don't use the dot, we just have parenthesis here, times m plus n, and then you close your parenthesis. So the parentheses are indicating multiplication here, so we don't have to put that extra dot or anything like that. Now the next one we have 7 more than y. So like 7 just translates as the number 7. And when you see more than, that's not, this is an expression. We're not doing a greater than symbol or anything like that. More than translates to addition. So that more than is going to be a plus that comes together as a plus. And then what follows that is y. So this literally translates as 7 plus y. So that more than becomes a plus sign when you're doing your translations here. Are there any questions on these two examples? Yes, there are going to be more with parentheses in there. Okay. So here's a couple more. We've got the product of -2 and the quantity x more than 5. So I'm going to start kind of going left to right here. Product means multiplication. And if you've got the product of, we're going to put the multiplication sign where our and goes. So I'm going to just put a dot there. And so we've got the product of -2. So we're going to have -2 times, and then it says the quantity of this and the x more than 5. So we've got lots of words following that. And so since it's lots of words, lots of things going on there, this is where we're going to have parentheses, because everything after the and is part of that multiplication. So we've got the product of -2, so that is telling us multiplication where the and is. We've got -2 in front of there, and then after the and, that's all grouped together as parentheses. Then we need to translate the quantity x more than 5. So when you see the word quantity, that's another thing that says put these in parentheses. So I don't have to add an extra set of parentheses. It's just extra words saying these are what follows is in parentheses. And sometimes you'll hear me say that when I'm reading algebra out loud. I'll say the quantity, and then it's assumed everything that follows is in parentheses. So we've already kind of translated the quantity because we've got those parentheses there. And then we've got x more than 5. So more than gets translated as a plus sign. And so we've got x on the left and then 5 on the right. And so now we've looked at all of the words here and translated them. And so when we put this together, we have -2 parenthesis x plus 5. So I don't need to put the dot. I only put it there when I'm translating just to make sure that I am remembering that I've got multiplication going on. But when we actually write our answer, we don't need the dot. So next one we have is the quotient. So quotient means division. And we usually write division as a fraction, but I'm going to write the division symbol, and you put that where the word and is. So I'm just going to put my division symbol where the word and is. So I've got the quotient of x. So x is on the left of my division symbol. And then everything that follows is in parentheses, because again, I have lots of things going on here. The difference of 5 and y. So there's more things going on than just one thing. So that's going to be in parentheses. So everything after that and is parentheses. Then I need to translate the difference. So that's subtraction. And that goes where the word and is. So I'm going to have my subtraction with that and symbol. And then I've got the difference of 5 and y. So I put those in the order that I see them. So now I've translated every word here. I've dealt with every word. So when I write this, I have x, and then the division we always turn into a fraction. And so now on the bottom of the fraction is what's in parentheses, and that's going to be 5 minus y. So in algebra, we rarely actually use the division symbol. We write things as fractions instead. And so you need to know that a fraction means division, because that's how you're going to see it. And then everything that's following that division symbol is in the denominator. That's why it's in parentheses. So we end up translating this as x over 5 minus y. Are there any questions? Okay, so a couple more here. We've got 54% of X. So this is starting to get into the kind of problems that you'll see in real life. You've got percentages. So if I read this in order, I've got 54. And the word percent means divide by 100. So the word per means divide. And then cent is 100. So there are 100 cents in a dollar. There are 100 years in a century. So cent means 100 and the word per means divide. So I translate percent as divide by 100. And then I have the word of. So when you've got a situation like this, we don't have words like added to or like difference of. We just have an of kind of by itself here. That's going to be multiplication. So frequently the word of is multiplication. If there's not a word that indicates addition or subtraction, it's going to default to multiplication. And then I've got X after that. So I've got 54% of X. So how we then write this after we've kind of translated it step by step is that divide by 100, we're going to make a fraction. So this is going to be 54 over 100 and then times X, or we'll write 54 over 100 X. So percent means over 100 essentially. And then we don't need the multiplication sign because we just have this number next to your variable that is assumed multiplication. So if you were to go further, you would then reduce your 54 over 100, but we're going to leave it because all we're doing here is translating. So when we translate into math, we don't use the percent symbol. We write it as over 100, whenever we're doing the translations. Next one, we've got 2/5. So that is a fraction 2/5. And it says the product. So product means we're going to be multiplying here with the word and. And so we've got 2/5 the product of 3 and X. So 3 and X. And so we need to sort of join these. We've got 2/5 and then 3 times X, but we've already translated all of the words. So this is where you can put parentheses. So we've got 2/5 of what follows. Sometimes you have to kind of put in an extra word there. It's 2/5 of, if you're thinking in your head, you've got this extra word that you kind of add in, of. So you can multiply by what follows. So we have 2/5, and then you can put in parentheses 3x. So I don't need the dots anywhere here. I can use parentheses to represent multiplication, and I can use, if you've got a number times a variable, you don't need a dot, you can just put them next to each other. So it's 2/5 parentheses 3x. Now we could go simplify this, kind of do that multiplication, but that's not what we're focusing here. We are just focusing on actually translating and taking these words and then understanding what they mean and how that gets written. There are questions. Okay. So moving on, these are in a slightly different color because now we're going to be doing mathematical statements. So if you see statement, that means you're writing an equation. So it's another way to say that you have an equation. So these are complete sentences. And so sentences get translated as equations that then you can go and solve. Now we're not being asked to solve here, we're just translating. So we have the sum of 31 and a number is 13. So we're going to translate the same way we've been doing. We've got the word sum, and you put the sum where the word and is. So I put the plus sign, sum means plus, I'm putting that where the and. And then I always make sure that I translate the is into my equal sign so that I know where things start or kind of end. When you're translating, you find where your equal sign is, and then the stuff to the left of the equal sign gets translated to the left. Everything that follows gets translated to the right. So that kind of tells you where to stop if you have things with parentheses and stuff. So we've got the sum of 31, so I can put 31 there, and a number. So if you have a number, that's where you put a variable. And if they don't tell you what variable to use, you can use any variable you want. You can use X, you can use Y, you can use anything. I usually use N for number. So if you are not specifically told what letter to use, you can choose any letter you want. I believe the problems do specify in ALEC, so you need to make sure you use whatever letter it tells you to use. But if it doesn't specify, you can choose anything. So I use N for number. So I've put in my 31 and a number. I have my is, which is my equal sign, and then to the right of the is 13. So I can just put in 13. And now I've translated everything, and this gives me my final equation here as 31 plus n equals 13. So I'm done translating that. Now, the next one here, we have the product of -3 and a number is the same as 24. So if we look for the is, if you want to do that first, is and is the same as, those all mean equal sign. So whether you have is or is the same, that translates as an equal. We've got the word product, and you put, that's multiplication, and you put it where your word and is. So I'm going to find that and, I put my multiplication symbol. And then I've got the product of -3. So I'm going to put a -3. And then we have a number. So I'll translate that as n. Then I have is the same as, so that got translated as equal sign, and then 24. So now I've translated all of the words here. And so we have -3n equals 24. So I don't need to put the multiplication symbol because it's a number times a variable. You can just put them next to each other. So we get -3n equals 24 when we translate this. Questions? Okay, so here are some more. We've got the value -3 subtracted from a number is 4. So is, that's going to be our equal sign. So I'll just kind of put that there. And when you see the value, that is just extra words. That's just saying, okay, the number that follows. It's meaningless. You don't even really need that. So it's just kind of extra fluff. We've got the word subtracted and we've got subtracted from. So that means we're going to be translating this in backwards order. So we're going to be putting a minus sign after whatever follows here, which is a number. So this is sort of flip-flopping your -3 and your number. They kind of get flipped-flopped when you see that subtracted from. So what that means is instead of having -3 and then a number, which I can use n, we're going to have the number first, then I'm going to subtract, and then -3. And I'm putting the -3 in parentheses because when you're subtracting a negative, it's good to put the negative in parentheses so that you don't accidentally lose negative signs. So I've just translated the -3 subtracted from a number, so that translates as n, or the number minus -3. And then I've got is, and then after that we've got 4. So this translates as n minus -3 equals 4. Next, we have 18 is equal to. So is equal to, so that's another one that's telling us that's where our equal sign is. So we've got is equal to the quotient of a number. So quotient means divide, and that's going to go where your and is. So I'm going to put my division sign. So quotient of a number, so I can use n, and 2. And then on the left of my equal sign, I just have 18. So I'm sorry, these colors, I'm trying to pick colors. I thought if I picked a different color, they might show up. It's showing up really badly. But we've got 18 is equal to, so that's your equal sign. Quotient is dividing, and we're going to translate that division as a fraction. So instead of writing n divided by 2, it's going to be n over 2. So 18 is equal to the quotient of a number and 2 becomes 18 is equal to n over 2. Are there questions on these two examples? Okay, so now I'm going to throw in, now we're going to start kind of getting into word problem types of things where you actually have situations that you have to translate. So we've got a farmer grew 4 acres more corn than wheat. So these types of situations, you often have more than one variable because you may have more than one unknown. And then you usually end up, if you wanted to actually have something you can solve, you put one equation into the other, you start kind of moving things around. So we're going to have more than one unknown here. So we've got a farmer grew, and that's kind of unnecessary here. Other than that's telling us, okay, we're kind of writing an equation here to represent. We've got 4 acres more corn than wheat. So when you've got something like this where you don't have the word is, it's you're trying to figure out where does everything go. This is one that's very commonly gets translated backwards. So you want to use your thinking here. We have 4 acres more corn than wheat. So there is more corn than wheat. So corn is bigger. We want to write an equal sign. So we want to write an equation where they are equal. So if corn is bigger, this means we need to add something to the wheat so that it's the same size as corn. So when we have 4 acres more, that's going to go with the wheat. We're going to be adding the 4 to the wheat so that it's equal to the corn. So this is a very common to translate backwards. So we've got 4 acres more is going to go with the wheat more. So we're adding 4 more acres. And essentially what happens is that our equal sign goes where we have the word than. And then we pick a letter for corn and a letter for wheat. So like we might use C for corn and then maybe W for wheat. So when you translate this, this becomes C equals wheat or W plus 4. Because if corn has more, then you need to add to the wheat in order to equal how much you have with corn. So this situation gets translated backwards a lot, but you'll see wording like this quite often. So it's really important to understand what that means and how it gets translated. The second one we have here is the width of a room is, so I've got my equal sign. So that's good. This one does have an equal sign that I can stick in. So the width of a room is 1/3 the length of the room. So we have 2 unknowns, width, which I can use W for width, and then I can use L for length. So we have the width is, so we can basically ignore the of the room. That's kind of unnecessary here. It's just kind of describing the situation. So we've got W equals, and then we have 1/3 the length. So if it's 1/3 something, there's an assumed of right there. So it's assumed multiplication. So we have 1/3 times the length. So this becomes W equals 1/3 L. And I used a capital L because I don't want it to look like the number 1. So I chose to do the capital so that it looks very different from my 1. So when you're starting to translate with word, with actual situations. So our previous examples, we translated pretty much every word exactly. Once you start getting in word problems, you have to start figuring out what words are important and which can be thrown out. You have to start figuring out what are my things that I'm looking for, that I'm interested in. What are the objects? Those are my variables. And then what of the stuff is just kind of extra. So in the first example, the fact that the farmer is growing something, that's kind of extra. You don't do anything with that. You just are comparing corn to wheat. Second example, the fact that you have a room is irrelevant because what we really care about is the width and the length of the room. That's our unknowns. That's what we're doing math with. So we don't care that it's a room versus a house or whatever it is. Those are just kind of descriptors. Are there questions on either of these 2 examples? Okay, so these are my last two examples. These are getting a little bit more complicated. So when Ms. Solano has excellent service at a restaurant, she leaves a tip of 20% of the cost of the meal. Write a statement given the amount of the tip T in terms of the cost of the meal C. So they're telling us what variables to use in this case. When you've got so I'm actually gonna, let's see, we've got T in terms essentially of C. We don't really care of the cost of the meal. We care, we've got T in terms of C. That's telling us we're going to have T equals to something that involves C. So C is going to be on the right side, and you're going to have T equals. So I'm translating that part first, because then I kind of know how the setup is. And I make my T's curved so it doesn't look like a plus sign. Now I need to go back to the first sentence and figure out, well, what is the mathy part of the sentence? A tip of 20% of the cost of the meal. So that's what we need to translate. We don't care about the words when Ms. Solano has excellent service at a restaurant. That has nothing to do with the actual math that's going on here. We have a tip that's 20% of the cost of the meal. So our tip is T equals. So our tip is equaling. And so you've got tip of, and then what is it equaling? 20% of the cost of the meal. So when we translate this, we've got 20, we've got percent, which we know is divide by 100. So that percent symbol gets translated as the word percent, divide by 100. And then of, because it says of the cost of the meal. So of means multiply. And then the cost of the meal is our next variable, C. So 20% of the cost of the meal translates as 20, the percent, so divide by 100 of, and then the cost of the meal is C. So when we put this all together, we've got T equals 20 over 100 C. Because they told us put T in terms of C. So T equals, and then what follows is going to be something that involves C. So then you have to kind of piece apart and go to the parts where you actually have numbers, where you have the things you're interested in, and you start translating that. Second example here, we've got the height of a sunflower plant can be determined by the time T in weeks after the seed has germinated. Write a model to represent the height if the height is given by the product of 9 and the square root of T. So the first sentence here is actually not really useful. It's not necessary for translating. They're just telling us that in that first sentence that we can write an equation for the height if we have the time since the seed has germinated. The second sentence is actually giving us the translation here. So it says write a model to represent the height h if the height is given by. So is given by is going to be a word or a phrase that is kind of meeting an equal sign here. So I have an equal sign. And to the left of that I have is the height. So height is our variable h. So I have h equals. And then it says is given by the product. So product is multiplication. So we're going to put a multiplication sign where we have the word and. So we've got the product of 9. So 9 is to the left of the multiplication. And then what follows is the square root of T. So square root, if you see the root, that means it's the square root symbol, and then t is going inside there. So whatever follows square root of, whatever's after the of goes inside the square root. So now we've translated the second sentence. And we have h equals 9. And I don't need the multiplication sign if I'm multiplying by a square root. And then the square root of t. So we have our height is given by, that's the word is there, that's telling us that's our verb, that's our equal sign. The product, so we knew that we're multiplying 9, and then we're multiplying by the square root of t. So the square root, you need to use the correct symbol, and then t is inside it. And so now we have now translated this equation. We have written a model for this situation. Are there any questions on these two examples? Okay. So no examples or no questions. That's a good sign. So thank you for coming. Hopefully this is helpful to kind of help you translate, understand the words, because this is going to show up a lot throughout the term. Let me stop recording.